Here we go. We're going to review these problems from this, what was that, Form 2C, Chapter 11 test, Form 2C.
Yep.
All right, and so let's draw this out. We'll go in order from the numerical order, okay? So from the area of a trapezoid. Alrighty. Looks like this, looks like that, and like that. Right? And we'll drop this down right there. Let's make that a different color. They make it dotted, but we'll make it red. I probably don't. Well, I've already started. Somebody else might have the same question. Now, the 18.4 is this whole thing, isn't it? From here to here.
It is?
Because it's right under that dotted line, and so it means it's the whole thing. Alright, is that it? And find the area. So what is the area of a trapezoid? What's the formula for it? Remember, it's the area of a T, right? So triangle, you know that. It's 1/2 the base times the height. So what's a trapezoid? It's 1/2 the what? Right, there's two bases, right? So you add the two bases together. That's supposed to be a B. And times the height. All right, well, we know both bases, so that's nice. So we just have to find what? The height. So if you just find the height, so if this is the height, so it has to be perpendicular to this. So this has to be a 30, 60, 90 triangle, correct? This would be the short side, wouldn't it? This would be the hypotenuse. So if the hypotenuse is 6, what's the relationship between the hypotenuse and the short side? Okay, the hypotenuse is twice as big as this, so the short side must be what? 3. Must be half of that. So, all right, so now you just plug it in, right? So it's 1/2. The two bases added together, so it's 12.6 plus 18.4 times the height, which you just found, which wasn't that hard to find, was it? Times by 3, stick it in your calculator, and you should get what I said the answer was, 46.5. So you should have gotten 46.5. Is that correct? Centimeters, so we'll put it centimeters squared. I won't mark off if you don't put this, but I tell you what, there are some teachers that will mark off if you don't put the units correctly. I taught physics for a lot of years at my other school, and that was really big into units. Okay, units were very, very important in physics, and so I did take off points if they didn't put the correct units down, or if they didn't put any units down. All right, but in geometry, I'm just more concerned about the number, but there are teachers that will be concerned about the units, so just be aware of that. All right, let's do another one. So that was number 4. Number 9 is next. Did somebody write these down? Because I don't want to have to write them down because I don't want to have to go up to the top every single time to remember which one's next. All right, so 9, 12 through 15, and 18. All right, good. All right, I already forgot. What are we doing now? 9? Okay, thanks. My memory's terrible. All right, let's do 9. It says, find the area of a regular hexagon with an apothem length. Okay, they don't give you a picture for this, do they? So what I do, this is what I do. You could draw a whole hexagon if you wanted to, but I'm just going to draw just a little part of it. Is that all right? I think that's easy enough. It might not be to scale. It doesn't have to be, right? So the rate or the center of that regular hexagon is about right here. And what do we always put in there? Yeah, the apothem. Okay, so let's put the, now it should hit halfway, right? So let's scooch this over a little bit to make it look a little bit more realistic. That looks a little bit better. So let's scooch our dot over now. There we go. That looks a little bit better, right?
That was too far to the right.
Nah, that's perfect. A little bit, but that's okay. It's better than it was. So then we also need these, don't we? That's probably going to be important. And why not just put that one right there? And a right angle. Okay, so that's how we started off. Now let's see what they tell us. They say with an apothem length of 4.3. So they actually tell us the apothem, don't they? So I'll put a 4.3 right there. That's the yellow. And we have to find the area of this thing. So how do we find the area? It's 1/2 the perimeter times the apothem. We already know the apothem, so really got to find the perimeter, which means I want to find this. Because it's a hexagon, right? So how many sides are there? There's 6 sides for a hexagon. So I got to find this. I don't know this. All right, let's do it. There's too much talking. Let's everybody listen. So first thing I do is I need to find basically I'm looking for this little side right here, aren't I? Okay, and then once I find this, I could double it, then times it by 6, or I could just multiply it by 12. Right. Does that make sense? Okay. No? Because if I... Oh, if I just said no. All right, so that's what we want to find right here. We need an angle, though, don't we? So that's how we're going to do this. This whole big angle we can find. Now remember, it's a hexagon, so there's 6 sides. So we take 360. Remember why it's 360? All right. And then divide it by what? 6, because there's 6 sides. And what would that be? 60 degrees. So this whole big angle is 60 degrees, but I just care about this little angle right there. And so we know that if this bisects a equilateral triangle, it bisects the angle, right? Or if this is an altitude of an equilateral triangle, it bisects this angle right here, which means that that would be 30 degrees. So now it's a 30, 60, 90. How about that? Right? This is the short side, this is the long side. So you could do a couple ways. You could just do this. Watch. 4.3 what? Yeah, you could set up a little thing, or... Nah, don't even do that. It's 30, 60, 90. It's easier. You could do this, the trig functions, but it's easier than that. Divide it by the square root of 3, right? Because remember, the long side is the square root of 3 times the short side. Okay? So if I know the long side, I have to divide by the square root of 3. So it's 4.3 divided by the square root of 3. Okay? You don't have to put it in your calculator right now. Wait to the very end and put everything in your calculator all in one shot. All right. So what do we got? We got 1/2, okay, times the perimeter times the apothem. We know the apothem is already 4.3. How do I write the perimeter? Remember what this is? This is just from here to here. But if I take this weird looking ugly number that we're eventually going to put in our calculator, and you just multiply that by 12. You could multiply by 2, then 6, but that's 12, right?
Wait, I forgot. Why do you multiply by 6 or 12?
Okay, listen. You multiply by 2 to get the whole length, right? Well, then you multiply that by 6 because there's 6 sides.
Oh, okay.
2 times 6 is 12, right? It's the third time I said that today. Okay, so there you go. And then you just stick all that in your calculator, and hopefully you get 64.1. And I'll let you do that in your calculator yourself. That's just a time waster for me. All right? Does that make sense? All right. Now, you may have used a trig function here, okay? And your decimal might have been just off a little bit. I'm not really sure. It just depends on how many places you rounded it and all that kind of stuff when you used your trig function. But it should be very, very close to 64.1, right? That should work. 12. Okay. All right, flip the page. 12. All right, area of that thing. So, actually, let's do this. Let's just use a rectangle tool, do that. Then we got a little semicircle, right? And I'm going to just draw it by hand. Oh, that looks pretty close. Actually, watch. You know how bad I am about this kind of thing. There we go. Oh, that looks pretty good. Alright, and here's the center right there. And this is 6.6. And the whole thing from here to here, right, is 14.3. There to there. Is that all they tell you? Nearest tenth. Alrighty. Yep. Yep, it's to here. So.
Oh, I'm so
right.
stupid.
No, you're not so stupid, but you saw it.
Yeah.
So watch. If you went to here, right?
I was so close.
Correct. No, it's half of the 6.6, right? Because this thing would rotate. Watch this in my cool program. Boom. Watch, see? Well, it's not exactly the scale, but you got it. From there to there, everybody see that?
Mm-hmm.
I didn't, I just hand drew that thing. But so what is that yellow one? 3.3. Yeah, and that was it. So you find, I don't have to do the rest, do I? You can find the area of the half circle, right? Pi r squared divided by 2. And then take, this would be what? 11, right? From here to here. 14.3 minus 3.3. Is that right? So that would be 11 from here to here. And then 6.6 times 11 is that. You add those two together, boom, you got your area. And number 12, let's see, that should be 89.7. If you do that correctly.
13.
All right, 13. All right. 13. All right, they don't give you a picture on this one either, do they? So you got to figure it out. The height of a triangle is 8 meters less than its base. If the area of the triangle is 212.5, find the length of its base and the length of its height. Okay. Now, we don't know exactly what kind of triangle it is, do we? And does it really even matter? No. As far as putting the numbers in, it really doesn't make any difference. So let's use a different color for the height. Not necessarily. No, you wouldn't. But I'm doing it just so everybody can kind of visualize what's going on. All right, you're right. You probably don't have to draw it, but I'm going to anyway. What's that?
Yeah. Our test.
It's tomorrow, yeah. So let's see. It says the height is 8 meters less than its base. So let's call the base, let's call it B for base. How about that? That's better next, don't you think? And the height is 8 meters less than this. So what is the height? It's B minus 8, right? All right. And it says, and it tells you the area of the triangle. They said the area of the triangle is 212.5. So you just kind of put this into a formula. What's the area of a triangle? It's 1/2 the base times the height. I know. That's right. What do we have to find? We have to find the base and the height. So we've written both of these in terms of B, correct? So really we're finding B. Wouldn't you agree? It does get... Okay. All right. Well, let's do this. If we solve for B, it's 2 times... Let's do this. Let's solve for B. I mean, you could put the numbers in right now, but I'm going to get B by itself. Do a little algebra, right? Wouldn't you? I would. I'm going to. I'm going to do the algebra, then I'm going to plug it in. It's the same deal. Because this is the way I'm doing it. Watch. So I solve for B. What is it? It's 2A, right? What? Divided by the height. Would you agree? Come on. It's basic algebra 1. How do you get rid of 1/2? Multiply by 2, right? So that gets rid of that. How do you get rid of the H? You divide, right? Or if you wanted to, you could do this. Let's do it. There's all kinds of ways you could do this. I'm thinking of another way. Let's just do this. Let's do 212.5. You know what I'm going to do? I'm going to put a times 2 here equals B times the height. What did we say the height was? It was B minus 8. So let's do it like that. That's probably the best way to do it. You like that way better? Because I got rid of the half. I multiplied both sides by 2 to get rid of that. So that's what? 424, 425? Is that right? Okay, so I've got, let's write the B on the left-hand side. 425, right? All right, so we distribute, so B squared minus 8B minus 425 equals 0.
That's what I got.
Okay, I'm not even going to bother to see if this factors or not. I'm just going to go straight to the quadratic. It does factor. Okay, let's pretend we didn't know that it factored. All right, so what could you always go to if you don't know if that factors nicely? Yeah, the quadratic formula. Okay, so we've done this on a couple occasions this year. Negative b plus or minus square root of b squared. I really doubt I'll put this on the test, but minus 2a. What? This is a nice formula. Okay, now what is the a, b, and the c? So a is what? 1. What's the b? It's negative 8. And what's the c? It's negative 425. Okay, so you just put those numbers in here. So this says the opposite of b, so that's positive 8, plus or minus square root b squared. So negative 8 squared is 64 minus 4 times a, which is 1, times c, which is what? Negative 425 over 2 times a, which is just 2. All right, so that's 8 plus or minus. Somebody do that. What's that? That's 850. That's 16. That's 1700. Is that right? Let's do that for me, quick. Is it 1700? Did I do that wrong? I don't know. I was just trying too fast. I'm trying to go too fast. All right, let's do this. So watch what I'm doing. I'm just going 4 times 425. That should be 850, and then 16. Oh, I don't know. I don't know. I should. 425. 1700. That's what I said. I said 1700. And it's positive 1700. That's what I was doing. I was just going 4. I know. I was saying 4 times 425 is 1700. And then 64 is 1764, correct? So let's do 1764, and then we're going to do square root of that, right? Oops, I'm thinking my other calculator. Square what? Square root 1764. Go ahead. Right. No, because you already made that plus. Look, you already made that plus. So there's no minus now. It's all addition. All right, so square root of 1764, 42. So I figured it came out even, especially when Morgan said it factors. So over 2, so what's that? 8 plus 42 is what? 50, right, over 2, which is 25. And then 8 minus 42 is negative 36, is that right? Over 2 is negative 18, is that right? But can you have a negative length? Because I'm solving for b here, right? You can't have a negative length, and so I'm not even going to worry about that one. I'm just going to keep that to be 25. So, where are we at now? B is 25. The height is 8 less than this, so what is that? It's just 17. So, 17 and 25. I just said a little bit ago, I probably won't have that on the test. Quadratic. Okay? But I'm not positive because I didn't look at the answer key or anything yet, so I don't know. But I usually don't on a geometry. Algebra 2, absolutely. 14. Area of a rhombus. Seems like we kind of just did this, right? It's a rhombus.
I think we just did it. We don't do it.
Yeah, I think that's okay because one diagonal is the length of the other. So call one diagonal D, call the other one 2D, right? And so I don't even have to draw this thing, do I? So let's see. What's the area of a rhombus? 1/2 D1 D2, right? So if one diagonal is D, the other is twice as big, so it's 2D. So it's what? 1/2, right? Times what? 2D. It should be D squared, right?
Yeah, 2D squared.
Yes, it should be 2D squared, right? And then that equals the area. 1/2 of 2 is 1, so the area equals D squared. They tell you what the area is, correct? Which is 49. That equals D squared, so D is 7. All right, so one diagonal is 7. The other one is twice as big, so the other diagonal, so D1 we'll call it, is 7, and D2 must be 14. Make sense? That was what, 14?
Alright, now what number?
15.
What do you mean? For this? You just call it says one diagonal is twice as big as the other. So I'm just going to call one diagonal D. The other diagonal is just 2D. Okay, multiply them together, there's your 2D squared. Okay? 15. Alrighty, area of a circle. So the area of a circle is 63.6. We don't have to draw this, do we? It says to the nearest tenth, what's the length of the diameter? So what is the diameter? So we're really not finding the diameter, really, are we? You're finding the radius. So really, let's find the radius. Because I have a formula. I don't have a formula for area of a circle with diameter in it, do I? But I do have an area of a circle with the radius. So area is pi r squared. So we're going to find the r. So let's plug the numbers in. So 63.6 equals pi r squared. So what do we do here? Divide by pi. right? And then square root it. Okay, you get an answer for that, so that's the radius, but you ask for the diameter. So what do you do with that? You multiply that by 2, and you've got the diameter. If you wanted to, you could do this. You could say the diameter is twice that, couldn't you? And then stick all that in your calculator in one shot, then you got your answer. Okay?
18.
18?
Yes.
Oh,
this is the last
that's
one.
that good one. I will draw this one. Yeah, we talked about this. I don't know. Who here to help? Emily, I helped you with that one yesterday? Okay, so you might have to remind me. I'm just going to try to draw this. I'm doing 18, yes.
I got this one right.
All right, this is 18. All right, let's see. This line goes to here, right? Let's make that a different color. And then let's make our triangle blue. So let me see if I can get this to look right. It says assume the triangle is equilateral. That makes a difference, doesn't it? Now, okay, so it's an equilateral triangle. So all. Now, what else do we know? It's not if it's equilateral. There's something else that we know about this triangle. It's equiangular. So what is this angle right up here? It's 60, isn't it? And that's 60. This whole thing is 60. Trying to think of a reason why. But what do you think this purple one's doing to this angle? Yeah. I'm trying to think why. Is there a reason why? Because it's a radius? Well, I know it's 30. So that's 30 right there, isn't it? But that bothers me. That bothers me a little bit. What? Right, but what am I trying to find anyway? I'm trying to find the area of the shaded region. What's shaded?
The circle. So the area of the circle minus area.
So it's just all this. So I have to find the area of the circle. I already know the radius, don't I? It's 10. That pink one right there, or purple, whatever color that is. That's 10. I didn't put that in there yet. Fuchsia. Yeah, it kind of looks fuchsia, doesn't it? So this would be, what, 10? Yeah, so the area of the circle is the easy part. Okay, it's just pi r squared, or pi 10 squared, right? So it's just 100 pi, right? 3.14, so it's 314, right? 0.2, is that what it is? 3.159, right? That would be, yep, 0.2. Okay, so that's that. Now we got to find the area of the triangle. That was the easy part, right? The area of the triangle is the part that's a little bit tougher. So how do we find the area of a triangle? What is the area of a triangle? It's what? It's 1/2 what? Base times the height, correct? Okay, so
I did it the hard way, I'm pretty sure. I did the apothem in that.
yeah, this is 30, this is 60 then, right? And that's 90. And then this is the hypotenuse, so we can find this. Yeah. Yeah. So, oops.
I did it like.
I'm off a little bit.
I did the hard way.
Give me a little grace here.
Oh man, that's gonna bother me.
Yeah, well, be bothered then. Sorry, but I'm not going to draw everything all over again just because of that. Alright, where'd my... Why is it that thing? Oh, what did I do again? Where'd my pen thing go? I did that before. What did I hit? Oh, I hit the caps lock thing. Whew. I accidentally hit caps lock. Was I being mean? I'm sorry. Caps lock makes it look like that, and then if I hit uncaps lock, it makes it look like a pen. That's all it does. What would you rather look at, that X or that pen? Okay.
Wait, do the X for a second. And then turn right. With the pen, you can see like what shape he's made.
All right, let's keep going. So let's see. So what's going on here?
It's the same thing. So wouldn't you just like times it by 3?
Yeah, this would be 10. Trying to find the height of this thing, right? Oh, okay. Yeah. So watch, that's 10. And now I can find, yeah, this is easy, watch. This is 10, and I can find this little bit right here. See this little purple one right here? It's 30, 60, 90. This is the short side, isn't it? So it's half of the hypotenuse. So this is what?
5.
It's 5, right? So from here to here, the height right there, the height of the triangle is 15. Now I just have to find the base of the triangle from here to here. So I got all this stuff on this triangle. If I can find from here to here, right? Then I just double it and I got the whole base. You could do Pythagorean theorem, absolutely. But what's better than that in this particular situation? It's 30, 60, 90. I don't have to really do much math at all. It's 5 square root of 3. That's better than doing Pythagorean theorem, isn't it? Because I just came up with it in my head, just like that. That's why it's nice. Stop the yapping. Come on. The whole time today I've been talking. I hear this murmur, and I don't like that, okay? Let's pay attention. So if you're answering questions, I'm fine with that. But having all these little conversations needs to end. All right, so this is 5 square root of 3. That's why it's nice to know about 30, 60, 90 triangles. Could you do this problem without knowing about 30, 60, 90? Absolutely, but it makes it a lot easier for you. So if this is 5 square root of 3, so is this. So what's the whole entire base? What is the whole base then? It's 10 square root of 3, right? Because it bisects that side right there. So yeah, so it's 1/2 times 10 square root of 3 times 15. Half of 10 is 5. 5 times 15 is what? 75 times the square root of 3. And that's your answer. Well, that's your answer for your area of the triangle. Okay? And then you take that 314.2, subtract 75 square root of 3, and now you got your shaded area. So that should come out pretty close to 184.3.
What I did, I did
Area of the shaded
perimeter
region.
and Apothem thing.
Right?
Because like a regular triangle or whatever.
Yeah, you could do that.
It's a lot harder than what you did though. I didn't.
You still have to find that side for the perimeter. The apothem would be that, right?
Yeah.
So that's all you have to find there. It would be the same thing. Yeah, it wouldn't be any more difficult, but it would be the same exact thing. Yeah. Because if you think about it, 1/2 the right, because 1/2 the perimeter times the apothem. Right, because I was going to say something else. I'm not going to. Yep, that's good. Anything else? Got a couple minutes. You got one more shot. 11. Test is tomorrow.
The height of the triangle is 15. Because the radius is if you just make it up. Yeah. We're stupid.
All right, this is number 11. This is a square. It's perpendicular. That's all you know, right? The whole thing is 8. Right, from here to here is 8. And then this is 6. And you're trying to find the area of that whole thing, right? Well, if all those are... So you find the area of this square. That's easy. That's 36, right? So if this is 6, what's the bottom of this thing?
2.
This is 2, isn't it? Okay. And this is 6. So that's 12 divided by 2 is
12.
6. 36 and 6 is 42. Boom, you're done. Just like that. All right. How much time do we have? What's this? Is it 13? What's this? 13? Okay.